A very good morning to all my dear friends. Welcome to Unacademy. So कैसे हो मेरे प्यारे दोस्तों? एक बार ऑडियो वीडियो जल्दी से कंफर्म कर दीजिए. Sorry. Please confirm the audio and video, my dear friends. ओके, तो स्टार्ट करते हैं सेशन को. मैं हूं आपका दोस्त ऐश्वर्य. पढ़ाता हूं आपको गेट ईएससी के लिए. आई हैव डन माई एमटेक फ्रॉम आईआईटी दिल्ली एंड बीटेक फ्रॉम जामिया मिलिया इस्लामिया. 4 times I have qualified GATE with my best AIR 226 and I do have 7 years of teaching experience and 2 years of industrial experience. और ये वो सब्जेक्ट्स हैं दोस्तों जो मैं पढ़ाता हूँ आपको अनअकैडमी के अलग अलग प्लेटफॉर्म पे, लाइक ऑन अनअकैडमी ऑफिशियल यूट्यूब चैनल, अनअकैडमी स्पेशल क्लासेस एज वेल एज अनअकैडमी प्लस. एंड द सब्जेक्ट्स आर थ्योरी ऑफ स्ट्रक्चर, आरसीसी, जियोटेक्निकल इंजीनियरिंग and strength of material. And my dear friend, this is a code which you can apply before buying any Unacademy Plus subscription. Not only in GATE and ESC field, but you can also promote this code in various other competitive field like SSC JEE, bank services, civil services, CBSE, NEET, IIT JEE, etc. So you can consider this code as an universal code at Unacademy. Okay. Now the question is, why do we need Unacademy Plus or Iconic subscription? So at Unacademy Plus, you will be having access to daily live classes, crash courses, weekly test, doubt solving sessions. So you will be getting the lectures in both the languages, English as well as Hindi. And apart from that, you would also be getting rank improvement batches. So all these features are being covered only under one subscription of Plus. But if you want to convert this Plus platform into your personal coaching, then you may also go for our Iconic subscription, in which you can say Iconic is a superset of Plus subscription in which all these benefits are will be available to you. But apart from that, we will be providing you here a local guardian, which is also known as your personal coach with Unacademy, who is going to plan your studies, who is going to keep study booster sessions, okay, and who is going to analyze your test at personal level so that it can be detected that what all are the areas where you guys are lagging. And not only this, you would also be getting some specialized notes and practice sets on the daily basis. So this is the most important feature of this, you can say, subscription. Okay, so now my dear friend, here are the details of you can say few our batches which we have recently launched. So you can see here that it is evolve batch. It is your evolve batch which is targeting gate 2022, which is targeting gate 2022. Okay, so this batch has been initiated by the top educators, and on 25th Jan we have launched this batch. So you can be a part of this, you can be a part of this batch, my dear friends, and you can use the code as 10. Similarly, if your target gate is gate 2023, अगर आप तैयारी कर रहे हो 2023 के लिए या आप अभी सेकेंड ईयर में हो, तो आप जा सकते हो हमारे एसेंट बैच के लिए. इट इज अगेन गोइंग टू बी, यू कैन से 2 ईयर बैच. ठीक है, 2 ईयर प्रोग्राम का आप सब्सक्रिप्शन लेके यू कैन बी ए पार्ट ऑफ दिस बैच, isn't it? Okay, so this batch is also, you can say, organized by our top educators, and you can see here, and it also started on 25th of January. Okay, अभी 2 ही दिन हुए. Okay, now my dear friend, those who are targeting the prelims exam of ESC, or those who want to be a ES officers and all, so if they are preparing and for their upcoming exam, which is in June or you can say July. So objective paper is there. Of non-technical will also be there. So for non-technical also we have started a batch of general studies, and you can be a part of this batch by using the code S10. Okay. चलिए. Yes, this is for my chemical friends. So chemical as well, we have launched 1 year course, okay, which is targeting gate 2022. It is, you can say, the batch A. Okay. So guys, you can unlock the free plans. You can unlock the free plan and you can use the invite code hashtag. Okay. So by after downloading the Unacademy app from Play Store or App Store, you have to use one invite code. So after using this invite code, all these free accessories will be unlocked for you, like special class, quizzes, combat, live test series, etc. Okay. So चलिए दोस्तों स्टार्ट करते हैं टुडेज सेशन इन Zenith batch. We are doing geotechnical engineering in the comprehensive manner, and these are the details of my upcoming sessions. So tomorrow morning same time 8:30 a.m. onwards we will be studying water content determination, and regarding today we do have several special classes. So first is scheduled at 2 p.m. in which we are going to, you can say, 2 p.m. Is the time. We are going to do some miscellaneous question on previous year questions, but in the miscellaneous format. And second is the test which I am going to take at 7:30. Okay, so 7:30 p.m. I am going to take a mixed test, and in my mix, you can say test, you would be getting RCC, steel, geotech. Okay, and you can say structures, and RCC steel geotech structures, and strength of material, and strength of material. So I will be bringing some questions from these chapters, you can say, okay, from these topics, and all these two classes I'm going to take on special classes. Okay, so this I'm going to take on the special classes. And just a minute, let me open the video on my device. Okay. Okay, so good morning Abhilash. So morning time, huh? Not many people are coming. Okay, so start करते हैं. Let us start the session, my dear friend. The topic is in situ density. The topic is now in situ density. My dear friend, what do you understand by in situ? In situ means at field. You can say at field conditions. Density means density of a soil at the field condition. See, although if somebody is seeing here that how to calculate density of the soil, then from a distance it looks very simple, that we have to measure the weight of the soil. We know that how much volume that soil is going to occupy. So simply weight over volume is your density, okay, or your unit weight, or mass over volume is your density. Okay, so that is a case here. So it is looking quite simple. But my dear friend, soil is quite, you can say, it is quite adjustable material, and it is going to change its volume very frequently. It is not a perfect solid, it is not a perfect liquid, okay, whose volume is not going to change. So at field condition, that soil might be having some particular volume, but whenever you are excavating the same soil, okay, and then you will be finding that its volume is not equal to the original volume which it was originally having at field condition. So getting the value of volume which is actually occupied at the field condition is quite typical task here. So that is the reason why getting the in situ density is slightly, you can say, trickier thing. But we will be having several methods in order to find the in situ densities. So let me explain to you them one by one. Okay. So whatever you are thinking, that is right, that whenever it comes to density means I have to calculate mass and I have to divide that mass with the occupied volume. Or if I want to work in terms of in situ unit weight, in situ unit weight, in that case you have to measure the weight and that particular volume. Okay, so both are similar things. And but how we are going to measure the volume occupied, that is going to be the trickiest thing in today's topic, my dear friend. Okay, so let us start. So my dear friend, so we are about to start this. We are actually preparing ourselves for our the soil classification. So see, determination of in situ unit weight. So in situ unit weight or density is also known as at field unit weight or density, as I told you earlier. So it is quite simple, weight upon volume. But what is tricky thing? Trickier thing is getting the value of exact volume. Getting the value of exact volume. Okay. So for getting the value of exact volume, so on field we actually are using these three methods. One is core cutter method, second is sand replacement method, and third is water displacement method. सर जी टेक्निकल इशू भी हो रहा है, शुरुआत में लिंक नहीं दिख रही थी. हाँ ये होता है, कल भी सेम चीज हुआ था. Yesterday also link were not visible, today as well. Okay, चलिए, don't worry. Okay, okay. So on field it can be determined by using core cutter method, sand replacement method, and water displacement method. Okay. So core cutter method I would like to start. So weight over volume. The entire game is of measuring volume. So core cutter method. What we are going to do in core cutter method? Tell me. So core cutter is basically your cylindrical vessel which is opened at top and bottom. Okay, which is open at top and bottom, and it is going to have the sharp edges. Okay, its diameter is 10 centimeter and its height, you can say, is 12.5 centimeter. Means it will look like this. It will look like this. This is your core cutter, but it is open at top as well as at bottom. Okay, this circular plate is not going to come. Okay, so remove it. Eraser is not working on this. Okay, I hope you got the concept. So core cutter is your cylindrical vessel which is open at top as well as at bottom. So you can say passage type, a tunnel type thing. But it is having sharp edges so that it can cut the soil and get itself inside. Okay, its diameter is 10 centimeter. Its diameter is 10 centimeter. Its diameter is 10 centimeter. What is happening? I can't understand. 10. Okay, it is 10 centimeter and its height is 12.5. Its height is 12.5 centimeter. Okay. Yes. So once again I am reminding you, it is opened at top as well as at bottom. Okay. Okay. Now see what is happening. You are excavating, you are inserting this core cutter with the help of some punching device into the ground, and you know the empty weight of core cutter, and once it gets punched itself into ground, then this core cutter is completely filled with the soil. Now whenever you are taking it out and you are measuring the weight on the weighing machine, now this time you are getting the value of weight of soil as well as of core cutter. So here guys, you know the empty weight of core cutter, which is, let's say, W1. Now you know after core cutter filling that it is going to have weight W2. So W2 is including the weight of soil plus core cutter. W1 is simply core cutter. So weight of the soil is how much? Weight of the soil is equal to W2 minus W1. Weight of the soil is equal to W2 minus W1. So weight of the soil is known to you now. Okay, weight of the soil is known to you, my dear friends. Now how to get value of volume of cylinder? Okay, or you can say volume of the soil, because we know the density is equal to your weight over volume. Weight you know now, weight is W2 minus W1, weight of the core cutter plus soil minus weight of the core cutter divided by volume. So tell me, my task was to measure the exact volume of soil which was covering in the field. So whatever is the volume, you can say, entrapped in this core cutter, so that volume is similar to that which it was occupying on the ground. Okay, you are simply punching in the core cutter. So whatever volume it was having at field condition, at in-situ condition, same volume you are even getting outside, because you are not going to change the arrangement of soil. You simply pushed in your device and you took it out, and whatever volume is there entrapped in the cylinder, that is equivalent to that volume which is it was originally occupying in the field. Okay. So measuring the volume of cylinder, okay, is equivalent to measuring the volume of soil which it was having at the original field condition. Okay, so volume of cylinder, you know, is equal to the volume of soil. So it is equal to pi by 4 d square h, and finally you can write that density or unit weight, if it is m2 minus m1 over volume of the core cutter, if it is about density, and if it is about okay, okay, my dear friend. Okay, now tell me one thing, my dear friends. You have to tell me one thing. I have written a note here. It is not suitable for dry and granular soil. Are you agreeing to it? Tell me. Are you all agreeing to it? It is not suitable for dry and granular soil. It is not applicable for dry and granular soil. Yes. The reason being, if the soil would be dry or cohesionless, or it would be having coarse particles, so you would not be able to entrap that soil into your core cutter. Whenever you are taking the core cutter out, so it will lose all the soil entrapped, because soil will not be having any self-standing, self-binding capacity. So soil would be having the self-binding capacity in case of silt, or you can say in case of clays. So if it is a matter of fine soil only, if it is a matter of dry soil only, so in that case soil will not be able to bind itself. Okay, so at field condition it is binding due to the gravitations and all, but whenever you are taking your device out, so that at that particular time soil is going to lose. Okay, so it is not suitable for dry and granular soil, isn't it? So this is the way to calculate the thing density from the core cutter. Okay, Sarji, then in case of dry soil core cutting, yes, exactly. Even core cutting is easier. Core cutting is easier. Okay, you are cutting the core. Okay, but whenever you are taking back your core cutter back, so volume entrapped would not be there, similar as that of field condition. So that is the reason. Okay. Okay. Next. Next is sand replacement method. Next is sand replacement method. This is also important, interesting as well. See, my dear friend, I'm telling you guys only one thing, that the entire focus you have to put on measuring the volume of soil. Okay. So in earlier case, especially in case of clay and silt, it was very easier to get the similar value of volume which those soil were having at its original condition. So, but when it is a case of dry sand, cohesionless soil like that, so in that case, what you guys are going to do? Okay, so sand replacement method, you can say, can generally be used for any type of soil, in fact, but you are using it for dry soil or cohesionless soil like that, and it is widely adopted in the field. Okay, due to its versatility in measuring the unit weight in all scenarios, and wherever there is a construction of road and highway, so you used to get the value of density by using sand replacement method. Okay, so now what you guys are going to do here, what you guys are going to do here, that you see, the mechanism is very simple. Suppose if this is your ground level, suppose this is your ground level. Okay, if this is your ground level, you are going to punch your device. Okay, you are going to excavate your soil. Let's say you have excavated this much of soil. Okay, and you can put this soil in a tray. I hope you are listening. You can put this soil on a tray, and you can measure the weight of this soil or mass of this soil into the laboratory or into on the weighing machine. Okay, that you will be doing. After that, what you can do? After that, what you can do? So this is W scenario, and after that, what you are going to do? You would be having one cylindrical jar which is completely filled with sand. Sand is just like your like your रेत जिसको आप लोग बोलते हो रेत सैंड उस तरीके का आप लेके आओगे यमुना सैंड्स लाइक दैट so you would be keeping a jar of cylindrical flask full with sand, and you would also be having the demarcations line on the cylindrical, so on the cylinder, which is actually calibrated. Okay, so with the help of depth of the sand consumed, you would be able to calculate its volume. Okay, so you are going to fill this volume with the help of that cylindrical jar of sand, and whenever you are opening the bottom of the cylindrical jar, so sand would be replacing this soil, because here soil is not there, so sand is going to occupy this volume, and a time will come when the entire volume would be covered. So at that point of time you have to stop the flow of sand, and you can measure how much depth is actually consumed of sand in that calibrated jar or in calibrated cylinder. So based on that depth you would be able to finding the volume of sand, and this volume of sand is as equivalent to that volume of soil which you have excavated from your field, isn't it? So why it is called sand replacement method? Because the volume of soil is actually replaced by the volume of sand, and the amount of volume of soil which soil was having in original, that is equivalent to the amount of sand which we have to uh, pour or put into your field. So sand is going to replace your soil. So that's the procedure is known as sand replacement method. Okay. So volume here you are calculating with the help of sand, cylindrical jar. So volume required to completely fill this excavated portion is V. This is weight and this is your unit weight. Okay. So all these, okay, good. All these unit weights are in bulk condition. Okay. All these unit weights are at field condition. Okay. So it is used for sandy, gravelly, silty, dry condition. हर जगह you can use this because no need of self-binding property. Okay, cohesion required. No limitations like that. Okay, because you are going to find the, you can say, volume with the help of third party, with the help of sand. Okay, so excavated portion, vacant portion is to be filled with soil. Is it clear? Okay. Next is third method, and this method is known as water displacement method. It is again a good approach. Mostly it is for your clays. Water displacement method. Okay. So understand, I hope you will be understanding the concept here. So see what we are doing here. See, the game is consisting of determining the volume of sand or soil. Okay. So in first case, volume was quite direct. Okay. Volume of the core cutter was equal to the volume of the sand or soil, you can say. In second case, sand replacement with the help of volume of sand consumed, you will be able to find the volume of the soil at field condition, and weight upon volume was the in situ density. Okay. And okay, so Abhilash is asking, sir, among all these methods, is sand replacement method is widely adopted concept? Yes, you can say. Yes, Abhilash. If it is a case of silt and clay, then I would be saying that core cutter is the most convenient. But sand replacement method is general. Sand replacement method is general. So that is the reason why I gave the note there that it is the widely adopted methods in the field. Okay. So now the third is, so there is a jar. So it is suppose initial, and after that it was somewhere here. So this height or this volume would be consumed and it was to be put here. Okay. So third one, water displacement. You have to understand the concept of water displacement very carefully. Okay. So let me explain this. What you have to do here. See, you have to coat your soil. Suppose it is your soil sample, maybe of clay, silt, etc. Okay, and you are coating it with wax. You know wax, paraffin wax. Okay, so suppose the volume weight of this soil was W1, and how you got this weight? You simply went to ground, simply went to field, and from there you have excavated some soil, and once you brought that soil into the laboratory, so you would be able to see that what is the weight of the soil. Okay, so you know this is the weight. Okay, so after that you have to see the volume. So how you are going to measure the volume? So it is a lump of mass, and you are going to apply, you can say, wax, paraffin wax over this soil. So now after applying the wax, the total weight of the system of the soil sample would be your weight of the soil plus weight of the wax. Okay, and yes, one important thing, the density of your wax is known to you. The density of wax which you are actually coating on your soil is known to you ना. जिस भी कंपनी का वैक्स लेके आओगे तो उसकी शीशी के ऊपर लिखा हुआ होता है इट इज द यूनिट वेट ऑफ द और इट इज द डेंसिटी ऑफ योर वैक्स. So now my dear friend, you know the weight of the wax. How you know the weight of the wax? Because you measured your soil earlier and its weights are W1, and after the coating of paraffin wax over your soil, now the weight is W1 plus W. Now the weight is including weight of the soil plus weight of the wax. So axis weight in addition to W1 is your weight of the wax. So weight of the wax is what? Final weight after waxing minus initial weight before waxing. So weight of the wax is now known to you. So now my dear friend, you need here density, and let me tell you one thing, density is very simple thing, or unit weight is a very simple thing. It is going to be the weight of the soil. Okay, and weight of the soil is how much here? W1 divided by volume. So here we have to see how we are going to get the volume. Here we have to see that how I can actually get the volume. Weight of the soil is known to me, that is equal to W1. Now it is about volume. So for volume, what gimmick I am doing here, I have first of all I have coated my entire soil with the wax. Okay, then I weighed the sample, then I got the weight of the wax, isn't it? So weight of the wax is this one. After this, what is going to happen? After this, what is going to happen? I have to see, I am simply you can say placing this system, soil plus wax system, into again a calibrated jar of water. Okay, so suppose this is a cylinder, and you know the readings here, it is calibrated and it was filled with you can say water. Okay, so when suppose it is your initial level, okay, so corresponding to this height, it was the volume of the water in the jar. Okay, now what is happening? When you are inserting here the mass of you can say it is wax plus soil phase, it is wax plus you can say soil plus wax, it is your wax plus soil. So due to inserting this lump of mass, what is going to happen? Its volume would be increasing because it is actually displaced water. So let me tell you, this is the final volume. Vi is volume at initial condition, and after the insertion of soil plus wax thing into your soil, volume has been lifted, height would have been lifted. So the volume of the, I can say, the volume of the soil plus wax, volume of the soil plus volume of the wax is the actually displaced water. Volume of the water which is displaced, it is Vf minus Vi. So you know how to get the value of Vf, you know how to get the value of Vi. Okay, so this is known to you, my dear friend. Okay, is it clear? Okay, so but the task here is not to find the volume of the displaced water. I have to calculate the density, I have to calculate the unit weight of the soil. So unit weight of the soil is weight of the soil, which is W1, upon volume of the soil only. I am not interested in this volume. I am not interested in displaced volume. I am not interested in the volume displaced by soil and water and wax both. I am only interested in the volume of soil. Okay, only in the volume of soil. Okay, So what I have to do now? What I have to do now? Okay, the purpose of adding wax, I hope you all got. Why I added wax here? Because wax is going to laminate this soil, and no external water is going to come inside the voids. So due to this, you can say the original intact volume of the soil sample can be obtained. Is it clear? Okay. So my task is to get the volume of soil, not of the volume of the water displaced. So volume of soil is how much? Volume of soil is, VW minus V of water minus V of wax. Okay. So VW is this one. And what is V wax? V wax is weight of wax, which is known to you, W2 minus W1, divided by unit weight of wax, which is as well known to you. In starting only I told you unit weight of the wax is known to you. It might be written on the, you can say, cover. Okay. So volume of water displaced minus volume due to the wax is the actual volume of soil. So you have to divide the unit weight with the volume of soil in order to get the in situ density. Okay. Obviously this approach we are going to use for your clays. You can say highly plastic and cohesive soil, where you can say cutting and all things become slightly difficult. So there we are going to use this technique. Okay. So I hope the concepts are clear to you. I hope the concepts are clear to you, my dear friends. Okay. Okay. Good. So any doubt? Only Abhilash is communicating. What about others, my dear friends? देखो नोटिफिकेशन अगर नहीं भी आ रहा है देन यू मस्ट बी नोइंग दैट मॉर्निंग टाइम नाउअडेज वी आर स्टडिंग कॉम्प्रिहेंसिव कोर्स ऑन जियोटेक. Okay. Next. I have some questions on these theory. So first question is from core cutter. Okay. So this is the height of the core cutter. This is the diameter of the core cutter, and its empty weight is 1071 grams. It is to determine the in situ density of soil. Core cutter weight is also given to you. It is 2970 grams, and moisture content is 6%. Then what is the in situ dry density? Okay, we have to find the porosity. Okay, if the soil getting fully saturated due to heavy rain, and what would be the water content and all. Okay, all these things are secondary. First of all, give me the bulk unit weight. First of all, give me the in situ unit weight. First of all, let us calculate that. Okay, we know the procedure. Just now we have seen the procedure. It is method number 1. So first thing is getting the value of gamma, or you can say rho here, because mass word has been used. So it is mass of the soil upon volume of the soil. So mass of the soil is how much? It is core with the soil is 2970, and empty weight of core is 1071. This is in gram. What is the volume of soil? Volume of the soil is pi by 4. It is equal to volume of the core cutter only. Pi by 4 d square into h. It is centimeter cube. So this is rho rho you are going to get in gram per cc. You are going to get the value of rho in gram per cc. Okay, so tell me how you are going to calculate this. Okay, so कितना आ रहा है, how much it is coming, tell me fast. Tell me, my dear friends. It is coming out to be, बताओ जल्दी बताओ. 2970 minus 1071 divided by pi by 4 into d square. So it is coming out to be 1.84. 1.84. 1.844 gram per cc. My dear friend, this is the in situ, you can say, density. So in situ density or bulk density, you can say, is 1.844 gram per cc. Yes. Okay, Abhilash. Now, my dear friend, here the first question which they have asked you, that what is going to be the in situ dry density. In situ dry density. You know what is there? What is written here right now? They right now the your soil is in this condition. Right now your soil is in this condition. Suppose this is your soil sample. Okay, so right now it is in this condition, that here is some soil, here is some water, this is your soil, this is your water, this is the air, and if total volume here is 1, if the total volume here is 1, okay, and the total weight here is how much? You can say 1.84 grams. So weight of, you can say, soil plus weight of water, it is going to be equal to 1.84 grams. This is what meaning, because the entire weight is due to soil and water and the entire volume is due to air, water and soil. So if its density is 1.84 gram per cc, it means 1.84 gram is there over 1 you can say centimeter cube. Okay, so this is going to be the concept here. Okay, now this you have obtained from the core cutter method, but you have to tell me, you have to tell me that what is the dry weight, what is the dry weight, dry unit weight. So when it comes to dry unit weight, so let me again redraw this sample. So this is your sample again. So if you want to measure the dry unit weight, if you want to measure the dry unit weight, if you want to measure the dry unit weight, then what to do? This is your soil. So dry means when all the water has been excavated. When all the water has been excavated. And again, my dear friend, this is going to be one. And obviously this time this weight is going to be less. This time this weight is going to be less A very good morning, big boss. Okay. So, who is going to tell me about this weight? Who is going to tell me about this weight? Tell me. Who is going to tell me about this weight? See, how much is the water content? Water content is given, it is 6%. It is 6%. Okay. My dear friend, with formula it is a one step answer. But again, I am making you learn that how to play with the block diagram, with the phase diagram. If water is 6%, okay, at its normal moisture content, it means if weight of the solid is equal to 6% of weight of the solid is the weight of the water. Okay, isn't it? And you know weight of the water plus weight of the solid is equal to 1.84. So just tell me the weight of the solid. Just tell me the weight of the solid. You know weight of the solid, it is the weight of the water upon weight of the solid is 6%. Means weight of the water is only 6% of weight of the solid and total weight is 1.84 grams. In that case, what is going to be the weight of the solid? This you have to tell. So weight of the solid you can calculate. Weight of the water is 1.06 or 0.06. Weight of the solid plus weight of the solid is equal to 1.84 grams. So weight of the solid is equal to how much? Weight of the solid is equal to how much? Tell me. बताओ कमेंट बताओ भाई. 1.84 divided by 1.06. So it is 1.73. It means weight of the solid is 1.735. So it means it is also 1.735. So it means that the dry unit weight here would be, or dry density would be this weight of the soil 1.735 gram per cc. My dear friend, this is a quite a bit lengthier approach. What you could have done, simply, you know that gamma d or rho d is equal to rho upon 1 plus w, or rho d is equal to rho upon 1 plus w. Array interrelation which we did day before yesterday. Okay, see, gamma d is equal to gamma upon 1 plus w. So this we did yesterday only. Okay, so from here you can calculate it. Yes, good, Abhilash. Okay, now my dear friend, what are the remaining questions? After that, dry density is known. Now it comes to porosity. Means what is the, you can say, volume porosity when it gets fully saturated. Okay, what is the porosity of the soil? First of all, tell me the porosity of the soil if the soil gets fully saturated due to heavy rain. Okay, and my dear friend, see here, if soil is going to be fully saturated, in that case you have to calculate the porosity. So tell me, if this is total 1, and this is 1.735, and G value is given to you how much? It is 2.69. And they are asking you the porosity. So tell me how it is going to work. Tell me. Now if this soil has to be fully saturated, then this all the air would be replaced by you can say water. Let me erase this. This time, Abhilash, I intentionally not following that formula approach. Okay, I see. Uh, in earlier question also, I could have used this now rho upon 1 plus w. It is a single step answer. But right now, I am simply making you learn that how to play with this block diagram. Even if you are not knowing the single formula, then still you guys would be able to solve each and every questions on phase diagram. Okay. Yes, I know that it is S into is W into G. It would be quite quicker. But from basics only, I want to crack it. Okay. So that I will be doing. So you know this concept as well. You know that basic one as well. Now you have to find the porosity when it gets fully saturated. Fully saturated means what? When all this air would be replaced with water. When all this air would be replaced with water. So this time this is going to be your block. So now here the entire game is of volume. If you are able to bifurcate the volume between soil and air, in that case it would be easier for you guys. In that case it would be easier for you. So when all the things with water, okay. So it is x. Let's say it is x. So it is 1 minus x. You know the value of g. G value is how much? G value is your 2 point kitna? How much it is given? 2.69. It is unit weight of the soil solid. Let's say it is 1.735 over x divided by unit weight of the water or density of the water, which is 1 in gram per cc. So from here guys you can calculate the value of x. See, G is the unit weight or density of soil solid with respect to density of water. So density of soil solid is how much? It is 1.735 over volume. So this, from here you can calculate the value of x. X is equal to 1.735 out of 2.69. So what is x here? Tell me. What is x here? Tell me my dear friend, what is going to be the value of x? Fast. So it is 1.735 over 2.69. So it is going to be 0.65. X is going to be nearly 0.65. So if it is 0.65, so what is this? This is 0.35. Do not go on to the scale. It is 0.65, it is 0.35. It means that porosity eta is equal to volume of the voids upon total volume. So it is going to be 35%, isn't it? Tell me. It is going to be 35%. Okay. Just a minute, my dear friend. Okay, yes. It is going to be 35%. Okay. Yes. Or you can say 36.4%. 35.4% even you can say. Approximately I have done. Okay. Or you can say 35.6% is also fine. Okay. And what about void ratio? Void ratio is equal to, it would have been how much? E is equal to 0.35 upon 0.65. So what is the value of void ratio? Tell me. 0.35 upon 0.65. 0.53, so 0.538. Okay, so this is your basic concepts. Okay, now if you want to get the results, then you can use, yes, S into E is equal to W into G. Okay, so S into E. So at degree of saturation 1, E you have to calculate, W you do not know, and it is equal to 2.69. Okay, so that is the case. So E is equal to 2.69 times of W, and you know the density is equal to G plus G gamma W upon 1 plus E. So E you know 2.69 W, and from here you can calculate the value of W. So W you would be getting, and after that you can calculate the value of E, and you can find the things here. Is it clear to all my dear friends? See now, my dear friend, gamma D is 1.73, gamma D is 1.73, G 2.69, rho W is how much? Gamma W is 1 in gram per cc. It is 1 plus E. So from here you can calculate E. From here you can calculate E. So E is same 0.538, and after E you can calculate eta and then the remaining thing. And once the value of E is known to you, you can substitute the value E in order to get the value of moisture content. Okay, do not put 6% because it is asking when it is completely saturated. In that case, what is the moisture content? Is it clear? So this is the formula approach, and these are the basic approach. Okay, and if the density of water is 1 gram per cc, then if 0.35 is the volume, then with respect to 1.735 grams, what is going to be the weight of the water? It is going to be 0.35 grams. Okay, so it is going to be 0.35 grams. So this time you can say 0.35 grams over 1.73 is your moisture content on fully saturation. So this is going to be your answer with this concept. I hope it is clear to you, my dear friends. Tell me if it is clear. Any doubt to anyone so far? Okay. Yes. So these two are the concepts. I hope you know it now. Chaliye. So, okay. So my dear friend, this is from water displacement. Take a snapshot of this and you have to attempt it by your own. So tomorrow I will discuss its answer. Take a snapshot of this. Okay, so similar thing. Mass is given, paraffin wax weight is given to you, and soil alone weight is given to you, and soil sample is displacing this much of water. Specific gravity of the soil solid is given to you. Specific gravity of the paraffin wax is given to you. Void ratio you have to find. Degree of saturation you have to find, and if the water content of the soil is 17%, and you know that unit weight of water is 1 gram per cc. In gram per cc it is 1 gram per cc. Okay, so this third question is also very good and important. Also take a snapshot of this, quite easy. You know the mass, you know the volume. Okay, it somehow it is mixed with the water content determination. So this question would be ideal to solve tomorrow when we will be done with water content determination technique. Okay, so do not solve this. We will be doing it tomorrow because here the moisture content is also required. So in tomorrow's topic we will be able to see how to get the value of moisture content, what are the various values, ways to calculate the moisture content. Is it clear? Okay. Okay, so let's keep the session up to here only, my dear friend. Today also we were late little bit, So I'll try to come on time, but today it was completely my mistake. Yesterday it was not mine. So let's keep up to here only. I'm sending you the notes in the Telegram channel within 5-10 minutes. Okay. So you can always post your doubts, queries in the comment of the videos. I am regularly watching that nowadays. So you can post the queries and all. Okay. And these are the details of my upcoming session. So tomorrow we have to deal with the water content determination and a few numericals. Session is going to start from 8:30 a.m. onwards. And if it is about you can say special class, then at 2 p.m. I'm going to take the you can say MCQs questions on structural analysis, gate previous year, and today I'm going to mix them. And a mixed test of civil engineering is also there at 7:30 p.m. onwards in the evening. Okay. Okay. Thanks. Okay, Abhilash. And my dear friend, this is some of our work at YouTube. You can watch. So I have already given you RCC and structures in the comprehensive manner, and it is going to be my third subject in full, you can say, detail. So it is the evolve batch for gate 2022 जो target कर रहा है आपका 2022 का exam, and it is your ascent batch for gate 2023 which is targeting your you can say 2023 gate exam. Okay. And my dear friend, this is target ESE prelims 2021 batch. Here general studies you are going to do, and for those who are preparing for ESC, they can go for this. And these all are the subscription plans of Unacademy. For 1 year you have to pay 27,225, and for 1.5 year you have to pay 34,650, and for 2 year plans, my dear friend, you have to pay 39,600. And if you are going for an iconic subscription, then 45,225 is the price, and 66,600 is the price for 2 year subscription. Is it clear to all? Okay. Guys, you can follow me at Unacademy at the rate Sharma Ashore 1049, and this is the official Telegram channel. Okay, here I'm going to send the daily notes, and all these are the various studies channel offered at by Unacademy, and right now you're watching me at Unacademy GATE CECH, which is known as the one-stop solution for all your civil engineering problem. Okay guys, thank you, thanks a lot. So see you soon tomorrow on YouTube, and today from 2 p.m. onwards on special classes. So thanks a lot. Have a nice day, and don't go outside if it is not required. Thanks.